Now I'm going to go over step 3, which is setting the alpha level. Setting the alpha level is actually pretty easy, and using it to compare to your p-values pretty easy. But understanding what an alpha level really is a little bit more difficult. So I'm first going to just describe what you do with the p-value later on in step 5 or step 4, whatever. And then I'm going to describe what an alpha level really is. So first you just set your alpha level. A common one is 0.05. And that's what you do in this step 3. That's all you do. You say alpha equals 0.05. That is all you have to do for step 2. But what you're going to do later on is to compare it to the p-value. So if your p-value is less than your alpha level, then you reject the null and you find support for the research hypothesis. So basically, you're just setting the alpha level so you know how small your p-value has to be in order for you to reject your null and find your research hypothesis to be true. Remember, our math is always about the null hypothesis, and we can only really prove something to be false. But because the null hypothesis is in opposition to the research hypothesis, then we can say that we find support for our research hypothesis. I know it's a little strange, but that's how you have to do it, because the math and the p-value is really about the null hypothesis. Alternatively, if the p-value is greater than your alpha level, then we fail to reject the null and we find no support for our research hypothesis. So if we set our alpha at 0.05 and we find our p-value at 0.03, then we would reject the null and find support for our research hypothesis. But instead, if our p-value was 0.07, then we would fail to reject the null and find no support for our research hypothesis. And we'll go in more detail about this later. I just want you to kind of get why we're setting it, so we can compare it to the p-value. But right now, this is all you do for step number 3, is just set your alpha level. Just write it down. That's all you have to do. And you want to make sure you set it before calculating the p-value. If you set an alpha level after you calculate the p-value, then you might be tempted to change it. You might be tempted to cheat. So example is, if your alpha level is 0.05, you find your p-value to be 0.06, so you change it later to 0.10, right? The alpha level is somewhat arbitrary. You want it to be a small value, but what actual value you set it at is a little bit arbitrary. So you can kind of cheat, but you don't want to cheat. You want to set it before you calculate your p-value. Some common levels are 0.10, 0.05, and 0.01. The most common is 0.05 in psychology. In other disciplines, there are other common levels that they use. In psychology, 0.05 is the one that's used almost all the time. Okay, so now I'm going to tell you what the alpha level means, and also what power is, and what a type 2 error is. So there's 4 things that could happen when you write your conclusion statement based on the p-value and how you compare it to the alpha level. So the alpha level is the probability of a type 1 error. And you said that. You pick what it is. And then you use that alpha level when you are doing calculations. I'll get to that later. But again, the alpha level is the probability of a type 1 error. A type 1 error happens when, in the population, This is the truth. In the population, the whole population, the null is true. And so our research hypothesis is false because the null and the research hypothesis are in opposition. But we take a sample, and based on that sample mean, we reject the null. We say it's false. Right? There's random error when you're sampling from the population. So sometimes we might get a sample mean that is totally off from the population mean, just by random chance. And if that happens, we might reject our null falsely. We shouldn't be rejecting the null, but we do. And that's a type 1 error. We don't want that to happen. So that's why it's in red here. Another thing that could happen when the population the null is true, we could fail to reject the null and we made the right decision. So that's here. That's in green, but it doesn't have a special name. Here in the second column here, in the population, if the null is false, so we say the research hypothesis would be true in the population, and we reject the null, we say the research hypothesis is true, then we made another correct decision. And this is called power. And the symbol for that is beta. That's another way we can make a correct decision. Another error, though, is a type 2 error. And this is when we fail to reject the null, but the null is false. And it happens to be 1 minus beta. So the null is false. So the research hypothesis is really true, and that's what the reality is in the population. But based on our sample, we fail to reject the null. We don't find enough evidence to find a significant finding. So we make a type 2 error. We want to have a lot of power, which means if there is a significant finding out there, if our research hypothesis is really true, then if we have high power, we have a high probability of rejecting our null and supporting our research hypothesis, which is really what we're trying to do as a researcher. We want to support our research hypothesis. But two things have to happen for that to happen. One, the null really has to be false, and meaning that our research hypothesis is true. And two, we have to have a lot of power. And if you read the document, you can see what affects power, and there's the sample size, the standard deviation, and how large of a difference there is from our null hypothesis to what reality is. So in our pizza example, if our null is that it equals 30 minutes for the average delivery time, but the real average is 31 minutes, it might be hard to detect a difference there. But if the real average and the truth is that it's 40 minutes and our null is 30 minutes, then it'd be easier to find a difference there. So just read that document about power and type 1 errors and type 2 errors. Read that. Hopefully this will sink in a little bit. Kind of talking about what ifs and hypotheticals, so I know it's a little hard to understand at first. Also, remember that we can directly affect the alpha level. We can kind of indirectly affect the power. by the sample size and some other things. But say our alpha is decreased. That means that our power, beta, will also decrease. So if we go from 0.10 to 0.05, we have less power. But our type 1 error is lower, so that's good too. So it's a trade-off between power and a type 1 error. So decreasing our alpha is good, but decreasing our power is bad, which will lead to, if we have a lower power, then we're going to have a higher type 1 error, which is 1 minus beta. So that's bad. So this is a type 1, type 2, and alpha is the type 1. So if we decrease our alpha, that decreases our power and increases our type 2 error. So type 1 errors and type 2 errors are related to each other. Again, read that document and hopefully it'll sink in a little bit.